Welcome to The Explainer. Today, we're going to tackle a concept that honestly feels a little bit like magic: sampling. How is it that we can know what millions of people are thinking just by asking a handful of them? Let's pull back the curtain and find out.
I mean, it really seems like it shouldn't work, right? How can a poll of just 1,000 people possibly predict how an entire nation is going to vote? Or how can a company test a new product on one tiny focus group and have any idea what millions of customers actually want? It just feels impossible. But it's not.
So let's dive in. And to do that, I want you to imagine we're stepping into what I like to call the Tao Salon of statistics. It's a place where we look for the simplest, most elegant path to the truth. And today, our whole journey is about finding the secret harmony that makes sampling so incredibly powerful.
Okay, so our journey starts with this really beautiful idea that a single drop of water can actually tell you a lot about the entire ocean. We've got to understand the connection between the little piece we can see and the massive whole that we can't.
And this, right here, is the absolute key. On one side, you have the population parameter. Think of this as the capital T truth. It's the real average height of every single person in a country. It's the answer we want, but, it's pretty much impossible to ever actually know. And on the other side, we have the sample statistic. This is our estimate, our best guess, that we calculate from the small group we actually measured. The entire game is about using the number on the right to make a really, really good guess about the mystery number on the left.
But how do we know our guess is any good? I mean, you can't just grab any old sample and call it a day. We need a method, a process that's designed to aim straight for that hidden truth. We have to find the true center.
And the secret to doing that is using something called an unbiased estimator. Now, that sounds super technical, but the idea is actually beautiful. Just think of it like a really good compass. Sure, it might wobble a tiny bit every time you look at it, but on average, it always points to true north. Well, our statistical methods are just like that. Any one sample might be a little off here or there, but the process itself, over the long run, is designed to be perfectly on target. It isn't flawed from the start.
Because the opposite of that is a biased estimate. And that's like using a rigged scale, or a compass that always points 5 degrees off to the side. It doesn't matter how many times you use it, it is always going to mislead you. So our first rule here in the Tao Salon is simple. Use methods that are fair, true, and unbiased.
All right, so we've got our unbiased tools, but we're still dealing with pure randomness, right? Every single sample we take is going to be a little different. So how do we get any kind of confidence or predictability from what looks like total chaos? Well, this is where the real magic happens.
Let's just do a little thought experiment. Imagine we don't take just one sample. Imagine we take hundreds of them, maybe even thousands. And for every single one of those samples, we calculate its average. What kind of pattern do you think would start to show up if we graphed all those different averages?
And here's the really wild part. It doesn't even matter what the original group looked like. The population could be totally skewed and lopsided, like maybe we're measuring income, or a few people make a ton of money, or customer reviews that are all clumped at 1 star and 5 stars. The starting point can be a total mess.
Because as we take more and more samples and we plot their averages, something absolutely incredible happens. Out of all that chaos, this beautiful, symmetrical, and totally predictable pattern emerges, the classic bell curve. Most of our sample averages will bunch up right around the true population average, and getting a sample that's way off becomes super rare. This is the harmony we were looking for. This amazing, predictable pattern has a name, and it is maybe the most important concept in all of statistics: the central limit theorem. It's the powerhouse that guarantees that if our sample is just big enough, the distribution of all those sample means will be normal, and that gives us the power to say exactly how confident we are in our results.
So, what's big enough? What's the magic number? Well, for most situations, the rule of thumb is a sample size of 30 or more. Yeah, just 30. It's not some strict, unbreakable law, but it's an incredibly powerful guideline. Once you hit that number, the central limit theorem really kicks in, and the predictable power of that bell curve is all yours.
Okay, so let's bring it all home. We've journeyed through the Tao Salon, and now it's time to put it all together. Let's recap the essential truths we've found and see how they actually work in the real world.
So here are the 3 big ideas from our journey. First, the reflection. This simple, powerful idea that our sample statistic is a mirror of the true population parameter. Second, the true center, the principle of using unbiased methods that are built to aim squarely at the truth. And third, the inevitable harmony, the incredible power of the central limit theorem, which gives us predictable, reliable confidence even when we're dealing with randomness.
And look, this isn't just some abstract theory. In the world of business and marketing, these principles are everything. This is why a survey of a few hundred customers can give you a crystal clear picture of your whole market. It's how you can A/B test a new button on your website with a small group and know with confidence if it's going to work for millions of users. It's the foundation of quality control in manufacturing and the secret sauce to spotting the next big consumer trend before anyone else.
So, the next time you see a political poll or a market research report, you'll know the secret. It's not magic, it's just this elegant, predictable harmony of sampling. And that leaves us with just one final thought. Now that you know the principles, what hidden harmony is just waiting for you to discover in your data?